Copper is one of the most widely used metals. Nearly 400,000 tonnes are used each year in the UK, mostly for electrical wiring, plumbing pipes, heat exchangers and coinage. At the IMI refiners in the West Midlands, copper is refined from scrap copper and other copper-containing waste. New copper, which has been extracted from copper ores, can be refined in a similar way. This is the only place in the UK where copper is refined. The site is crossed by the Midland Motorway network, but the original choice of location was so that it was close to the traditional metalworking industries in the Midlands. Impure copper is melted in a furnace and cast into anodes for electrolytic purification. During electrolysis, the anodes dissolve and pure copper is deposited onto stainless steel cathodes. This yields copper of 99.995% purity, which is then remelted and cast into billets. This high degree of purity is required for electrical use. At IMI, the scrap metal is collected and melted here. This building houses the electrolysis cells. Copper is remelted and cast into billets to be stored on this part of the site. Copper scrap is heated in a blast furnace with limestone, coke and air. This produces an alloy containing 80% copper and slag, which can be sold as an abrasive. Further treatment in a second furnace gives 96% pure copper, which is fed into the anode furnace. Copper from the anode furnace, about 99% pure, is cast into a strip which is cut into anodes. These are about 1 metre square and weigh 375 kilograms. This is the electrolysis cell room. It houses 288 cells and uses a total current of 24,000 amps. The copper anodes are sandwiched between stainless steel cathodes in sets of 39 anodes and 38 cathodes. They're placed in an electrolysis cell containing an electrolyte of hot sulfuric acid and copper sulfate. The anodes dissolve in the electrolyte to give a solution of copper ions, and pure copper is deposited on the cathodes. Impurities of other metals in the anodes do not dissolve and sink to the bottom of the electrolysis cell, producing anode slime. Anode slime is valuable and is sold so that the precious metal residues, including silver and gold, can be extracted. Once a week, the cathodes, with a 6 mm thick coating of copper on each side, are removed from the cells. The deposited copper is separated from the cathodes by flexing them and stripping the copper away with knives. Plastic strips prevent copper being deposited on the edges of the cathodes. The steel cathodes are then reused. Anodes last 3 weeks before being removed and replaced. About 12% of the anode remains after this time. These spent anodes are washed to remove further precious metal residues and recycled back into the anode furnace. The electrolyte eventually becomes a mixture of copper and nickel sulfates. It is continuously bled off and the copper removed. This leaves a solution containing nickel sulfate. The water is evaporated off, leaving impure solid nickel sulfate for sale. Most of the pure copper from the cathodes is melted down in a furnace and cast continuously into circular sections of different sizes, known as billets. Rollers pull the bar away from the mould as the copper solidifies, and the bar is cut into the required length. These billets are sold to customers.